Today we're going to talk about measuring with a microscope again. Sometimes it's very difficult to get a measurement underneath the microscope, especially if you have a higher magnification. The problem is as you increase the magnification, you decrease your field of view. As you magnify the image more, you actually see less of the entire image. And that's what's considered to be your field of view, the view that you're actually looking at. When we look at a 100x specimen underneath the microscope, it's going to look very different than if we were looking at it under 400x. So we're going to learn a little bit of a formula today in order to figure out what the diameter of a specimen is when we have a change in magnification. The specimen really does stay the same size. Its actual diameter doesn't change, even though you have increased the magnification. It just appears to be a different size. So we're going to learn our formula today. We're going to take the change in magnification in order to figure out how much we need to either multiply or divide by. So the way the formula goes is you take your lower magnification, so in this case it's going to be 100x, multiply it by x, which is going to be our unknown, and that's going to be equal to whatever your higher magnification is. In this example, it's going to be 400x. So when we multiply 100x equals 400, we solve for x. X is going to be equal to 4. That means we've had a change in magnification of 4 times. 100x going to 400x is 4 times greater in magnification. So that means our magnification increased 4 times, which, remember, if we increase our magnification, our field of view is decreasing. So let's have a real example. If we're looking at an organism under 100x and our field of view is 1200 micrometers, what would the size of the organism be if we increase the magnification to 600x? So in this case, we're going to take our change in magnification. So we went from 100 to 600x. So we have a change in magnification of 6 times. It's 6 times greater. So we've increased the magnification, therefore we've decreased the field of view 6 times, meaning we're going to divide by 6 in this instance. So for the field of view of 100x, the field of view is 1200 micrometers. Under a field of view of 600x, what would it be now? So we take our 1200 micrometers, divide it by 6, and we end up with 200 micrometers. The 1200 divided by 6 because we increased the magnification 6 times. So our new field of view is actually only 200 micrometers. That's helpful for us to understand in terms of estimating the size of an organism when we have increased the magnification. We no longer can put that clear plastic ruler on the stage when we're at a magnification of 600x. So let's try this again. If we're at a magnification of 400x and the known field of view is 1000 micrometers, and we're going to decrease our magnification to 200x, what would our new field of view be? Well, the change in magnification is actually a decrease. Our lower magnification is 200, our unknown, and then we equal that to our higher magnification, which in this case is 400. X, when we solve for it, becomes 2. We've decreased our magnification 2 times, meaning we've increased our field of view 2 times. If we increase the field of view, that means we're going to multiply. So instead of dividing in this example, we're now multiplying. So the field of view at 400x was 1000 micrometers. What would it be if we had a magnification of 200x? Well, we would take that 1000 micrometers from our field of view under 400x, and we would now multiply by 2. Remember, when we're decreasing the magnification, we're now going to be multiplying. So we take that 1000 micrometers, multiply by 2, in order to get a field of view now of 2000 micrometers. Notice that it's that factor of 2 again. Now let's see if you can do one with me. If we have a magnification of 200x, we have a couple of organisms here in our field of view, and we change the magnification to 400x. This is just an estimate of what they would look like when we do that. What would the size of the cell be? We can figure that out. We know that the field of view for 200x had a diameter of 1.2 millimeters. 1.2 millimeters, remember, we need to convert into micrometers. And if you remember, we do that by multiplying by 1,000. So 1.2 millimeters multiplied by 1,000 is actually going to become 1,200 micrometers. So our field of view for 200x, we're changing that field of view now to 400x, remember. So let's do the calculations. So why don't you pause and try the problem on your own. Now that you've tried it on your own, let's see how we did. If our field of view, we know at 200x is 1,200 micrometers, and we can fit 4 of those cells across my field of view, I'm going to take my 1,200 micrometers, divide it by my 4 organisms, and the size of one cell is 300 micrometers. My field of view at 400x, remember we have to do our formula that we had before. So we went from a field of view of 200x, or a field of view with a 200x magnification. Now we've changed our magnification to 400x. So we remember we take our lower magnification, multiply by x, equal to our higher magnification, in this case was 400. When we solve for x, it becomes 2. Since we're increasing the magnification, we're going to multiply by 2. So our field of view now, in this case, sorry, I apologize, we're going to be dividing by 2. In this case, our field of view is 1,200 micrometers. 1,200 micrometers divided by 2 is now 600 micrometers. And if I try to figure out the size of one cell, you can see that I can fit 2 cells across that field of view. If my field of view was 600 micrometers and divide that by 2 to get the size of one cell, you can see that even though I've increased the magnification and the cells appear to be larger, those cells are still the same size. Under each of the instances, one cell is still only 300 micrometers in diameter. Let's try one on our own. Let's use this example, pause, and try to solve it yourself. You're given a magnification of 400x with a field of view of 800 micrometers. Try to solve and see what the new field of view would be if you've changed to a magnification of 100x. Let's see how you did. If we have a magnification of 400x and we've changed to a magnification of 100x, we're taking our lower magnification of 100 multiplied by x equal to our higher magnification of 400. We've decreased the magnification, which in this case we're going to be multiplying. We increased our field of view. So in this case we're going to multiply by 4. Our original field of view was 800 micrometers. We're going to multiply by 4. Our new field of view is 3,200 micrometers. That should make sense because as I decrease the magnification, I can see a greater diameter or a larger field of view of my organism. So this number should get bigger. In this case, it got bigger by a factor of 4 because we decreased the magnification 4 times.